I'm so glad you found your way here tonight. Right now, while you rest, your brain is preparing to do something no other known object in the universe can do. It will build an entire world from nothing, and then step inside it. Tonight, you'll discover the science of lucid dreams, and by the end, you'll understand why the dreaming mind may be one of the most extraordinary places in existence. Welcome to Sleepy Mind Science. Wherever you are right now, perhaps lying in the quiet dark, perhaps feeling the gentle pull of tiredness already settling in, allow yourself to sink a little deeper. We'll journey through 100 science facts about lucid dreams. From the first moment researchers discovered dreamers could signal from within sleep, to the hidden architecture of the dreaming brain, to the quiet question of what consciousness truly is when the body is still. These quiet explorations of the dreaming mind build a sanctuary for curious souls who can't quite let the world go at night. A gentle subscribe, like, or sharing this with someone helps other restless minds find their way here and brings us closer to protecting this peaceful space, one sleepy soul at a time. It means everything to us that you're here. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. A lucid dream is a dream in which you know you are dreaming. That single sentence sounds simple, but it describes something that puzzled scientists for most of recorded history. For centuries, philosophers debated whether such a thing was even possible, whether the sleeping mind could hold enough awareness to recognize its own dreaming state. The answer, confirmed repeatedly in sleep laboratories since the late 1970s, is yes. The dreaming brain can, under certain conditions, become partially aware of itself. This awareness changes everything about what sleep can be. The first scientific evidence that lucid dreaming was real came in 1975 when British psychologist Keith Hearne, working at the University of Hull in England, recorded the first verified eye signal from a dreaming volunteer named Alan Worsley, using an electroculograph, a device that tracks eye movement. Hearne observed a prearranged sequence of left-right eye motions produced by Worsley from within a dream. It was the first time a message had ever been sent from inside the dream state and recorded by scientific instruments. Stephen LaBerge at Stanford University would later conduct similar experiments confirmed by full polysomnographic recordings, publishing the results in 1980. And it was his work that brought the discovery to wider scientific attention. Together, their contributions transformed lucid dreaming from philosophical curiosity into a field of study. Lucid dreaming occurs most often during REM sleep, rapid eye movement, sleep. REM is one of the most active phases of the sleep cycle, characterized by a brain that looks, on an electroencephalogram, almost indistinguishable from a waking brain. The eyes move rapidly beneath closed lids. The body enters a state of near-complete muscle paralysis, a natural protection that prevents us from physically acting out our dreams. Within this paradox, a deeply asleep body, and a vividly active mind. Lucid dreams take shape. The first full REM period of the night typically begins about 90 minutes after falling asleep. Throughout the night, REM periods grow longer. The first may last only 10 minutes. By the final sleep cycle of an 8-hour night, REM can extend to 30 minutes or more. This is why lucid dreams, which require a certain degree of cortical activation, are far more likely in the early morning hours. During those long, rich REM windows that arrive just before natural waking, surveys conducted across multiple countries suggest that somewhere between 40 and 60% of people have experienced at least one lucid dream in their lifetime. Among younger adults, the frequency is higher: regular lucid dreamers. Those who experience the phenomenon at least once a month make up a smaller group, commonly estimated at around 20% of adults, though some surveys suggest higher rates among younger populations. The ability to achieve lucidity reliably and on demand is considerably rarer still. During a lucid dream, specific regions of the brain activate in ways that distinguish it from ordinary dreaming. Research using functional magnetic resonance imaging, fMRI, and electroencephalography, EEG, has consistently shown increased activity in the prefrontal cortex during lucid compared to non-lucid REM sleep. The prefrontal cortex is the region most associated with self-reflection, rational thought, and the awareness of one's own mental states. In ordinary dreaming, this region is relatively quiet. In lucid dreaming, it awakens selectively and partially, while the rest of the dreaming architecture continues undisturbed. The prefrontal cortex's role in lucid dreaming gives it a particular significance in neuroscience. This region is sometimes called the seat of metacognition, the ability to think about thinking. When it activates during a dream, it allows the dreamer to observe the dream from a slight distance, to recognize that the experience, however vivid, is internally generated. It is one of the clearest examples in neuroscience of the brain watching itself in real time. The brainwave patterns underlying lucid dreaming are still being mapped, and what researchers have found is more nuanced than early studies suggested. For many years, a rise in gamma frequency activity, around 40 Hz, in the frontal brain regions was thought to be the signature of lucid awareness during sleep. More recent work, including a large, multi-laboratory study completed in 2025 that pooled data from 5 research centers, has refined this picture. That earlier gamma finding may have reflected eye movement artifacts rather than neural activity unique to lucidity. What does appear more consistently across studies is a reduction in slow delta wave activity during lucid dreaming compared to ordinary REM sleep, suggesting a locally lighter depth of sleep in certain brain regions during the lucid state. The science here is still being carefully written. In 2014, a German research team found that applying mild electrical stimulation to the scalp at frequencies between 25 and 40 Hz could, in some participants, be associated with reports of lucid dreaming. The finding, published in Nature Neuroscience, was widely discussed, but it has proven difficult to replicate cleanly, and the relationship between external brain stimulation and genuine lucid awareness remains an open and active question rather than a settled answer. This is not a weakness of the science. It is the science doing what it does best: remaining curious, remaining careful, and refusing to close a door before the room is fully lit. So from the very beginning of this journey, something is already becoming clear. Lucid dreaming is not magic. It is not mysticism dressed in laboratory language. It is a neurological state, measurable, reproducible, and increasingly well understood, even as new findings continue to refine that understanding. And yet, within all of it, something remains genuinely worth wondering about: the fact that awareness itself can persist inside the sleeping brain, like a small light left on in a house where all the other lights have been turned off. The history of human interest in lucid dreaming stretches back thousands of years. Aristotle, in his writings on sleep and dreaming, known as the Parva Naturalia, noted that during sleep, it is sometimes possible to be aware that what one is seeing is a dream. One of the earliest written records of what we now call lucid dreaming. Tibetan Buddhist monks developed a practice called dream yoga, dating back more than 1,000 years, specifically designed to cultivate lucid awareness during sleep as a path towards spiritual insight. In many cultures, the transition between sleep and waking was understood as a liminal space, neither one thing nor the other, where the boundaries of self could be quietly examined. The word lucid, in this context, comes from the Latin lucidus, meaning clear or luminous. It was the Dutch psychiatrist Frederik van Eden who first used the term lucid dream in a formal written report in 1913. After keeping a detailed dream journal for over 2 decades, Van Eden documented more than 350 lucid dreams in his own sleep, describing them as clearer and more vivid than ordinary dreams. With a quality of alertness that ordinary dreaming lacked, his careful observations helped set the stage for the scientific investigations that would follow. Children appear to experience lucid dreams more frequently than adults. Research suggests that the boundary between sleep states may be more permeable in younger brains, allowing for easier transitions into hybrid states of awareness. Nightmares in childhood may sometimes transform spontaneously into lucid dreams. As the sleeper recognizes the threatening scenario as a dream and gains a degree of control, this natural lucidity in childhood tends to decrease with age. Though it can be gently recultivated through practice, there are several validated techniques for inducing lucid dreams, and research has tested many of them with increasing care in recent years. The most widely studied is the mnemonic induction of lucid dreams, known as MILD, developed by Stephen LaBerge. It involves waking briefly during the night, setting a clear intention to recognize when you are dreaming, and then returning to sleep while holding that intention in mind. Studies suggest MILD is among the more effective single techniques, particularly when practiced during a brief awakening after 5 or 6 hours of sleep. Another well-studied induction technique is wake back to bed, sometimes abbreviated WBTB. The method involves waking after approximately 5 or 6 hours of sleep, remaining awake for a short period, perhaps 30 to 60 minutes, and then returning to sleep. Because this re-entry into sleep often leads directly into REM, the dreamer is more likely to enter a state where the brain is active enough to support lucid awareness. Used in combination with MILD, WBTB has been found to meaningfully increase the rate of lucid dreaming in controlled studies. Reality testing is a behavioral practice often recommended to those who wish to develop lucid dreaming. It involves regularly asking, throughout waking life, the question, "Am I dreaming?" and then performing a specific check, examining one's hands, attempting to push a finger through the palm, reading a piece of text twice to see if it changes. Over time, this habit of questioning reality can carry over into dreams. When the same check is performed in a dream, the dreamer may notice that the text shifts or that the finger passes through the palm, gently triggering the recognition, "This is a dream." The dreaming brain generates an extraordinary degree of sensory detail. During a vivid REM dream, the visual cortex, the auditory cortex, and the regions associated with touch, smell, and emotion are all active. The brain is not merely imagining these sensations, it is constructing and experiencing them in real time, using many of the same neural pathways as waking perception. This is why dreams feel real. The brain has no shortage of material for this construction, drawing on memory, emotion, expectation, and the patterns of experience accumulated over a lifetime. In ordinary dreams, we rarely question what we are experiencing. The dreaming brain, operating without the prefrontal cortex's usual moderating influence, accepts even the most implausible scenarios without hesitation. People we know appear in impossible places. The laws of physics bend without comment. We accept it all because the part of the brain that would notice the impossibility is largely quiet. Lucid dreaming represents the partial reactivation of that patient. Questioning faculty, enough to register the strangeness, but not enough to wake up. Research has explored whether skills practiced in a lucid dream can transfer to waking life. A series of studies found that motor tasks rehearsed during lucid dreams, such as specific finger movements or simple physical techniques, produced measurable improvement in waking performance. The effect was smaller than physical practice, but larger than mental imagery rehearsal alone, suggesting that dreamed practice occupies a genuinely useful middle ground. These findings have drawn interest from researchers in sports science and rehabilitation. The question of control inside a lucid dream is more nuanced than it might seem. Becoming lucid, recognizing that you are dreaming, does not automatically grant unlimited control over the dream's content. Many lucid dreamers report that the dream continues to unfold with a kind of momentum of its own, and that deliberate changes require focus and effort. Some dreamers find that certain aspects of the dream environment respond readily to intention, while others quietly resist. The relationship between the aware dreamer and the dreaming brain is, in this sense, a collaboration rather than a command. In 2021, a paper published in the journal Current Biology described 4 independent research groups in France, Germany, the Netherlands, and the United States, who held real-time exchanges with sleeping lucid dreamers. Working with 36 participants, the teams found that dreamers could correctly answer simple arithmetic questions and yes or no questions while remaining in REM sleep, responding through prearranged eye movements and facial muscle signals. Correct answers were confirmed on 29 occasions, across 6 of the individuals tested. That 2021 study demonstrated not just that lucid dreamers are aware inside dreams, but that they can receive information from the outside world, process it, and respond meaningfully, all while in REM sleep. The findings opened new directions in sleep neuroscience and raised questions that researchers are still working to answer about the nature of consciousness, the permeability of the sleeping mind, and what other forms of communication might eventually become possible. It was, by any measure, a quietly significant moment in dream science. Lucid dreaming has been investigated as a potential tool for managing recurring nightmares. Nightmare disorder, characterized by frequent, distressing dreams that disrupt sleep, affects a notable portion of adults, with particularly high rates among people with post-traumatic stress. Image rehearsal therapy, a well-established treatment, involves rewriting the narrative of a recurring nightmare while awake and then rehearsing the new version. Lucid dreaming offers a complementary approach, the ability to recognize a nightmare as a dream while it is happening and to engage with it rather than simply endure it. Clinical research on lucid dreaming as a therapeutic tool has grown steadily in recent years. A 2022 analysis found that lucid dreaming training reduced nightmare frequency in samples that included people with post-traumatic stress disorder, with results comparable to other approaches. The research is still developing, and the field continues to refine its training protocols. But the evidence is growing that the awareness available in a lucid dream is not just a neurological curiosity. It may be genuinely useful for certain forms of distress. And so, 25 facts in Something is already becoming clear. Lucid dreaming sits at an intersection unlike any other in human experience. It is ancient and newly scientific. It is deeply personal and increasingly measurable. It is the brain watching itself in the only place where the watching is itself a form of dreaming. From here, we go deeper into the architecture of sleep, the chemistry of awareness, and the quiet question that has been gathering at the edge of every fact we've explored so far. Let's pause here and notice your body as you breathe out slowly. Appreciate each tiny cell inside. Trillions of cells working in quiet coordination. Heart beating, lungs breathing, brain preparing its own quiet architecture for the night ahead. All without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem. Diverse. Self-balancing. Now we continue. Here is phase 2, covering facts 26 through to the end of the script. The sleep cycle that contains lucid dreaming, REM, is one of the most metabolically active states the brain enters. During REM, the brain's oxygen consumption rises significantly, comparable in some regions to waking levels. The brain is not resting during REM sleep. It is working, consolidating emotion and memories, processing social experiences, integrating learning from the day before. Lucid dreaming occurs inside this intense neurological activity. Not despite it, the neurotransmitter acetylcholine plays a central role in REM sleep. Its levels rise sharply during REM periods and are thought to contribute to the vivid, narrative quality of dreaming. Substances that increase acetylcholine activity in the brain have been found in some studies to increase both dream vividness and the likelihood of lucid dreaming. This connection between cholinergic activity and dreaming awareness is one of the more consistent findings in the neurochemistry of sleep. Norepinephrine and serotonin, two neurotransmitters Kenyesta highly active during waking life, drop to very low levels during REM sleep. This chemical shift is thought to be one reason why dreaming feels different from waking experience, why time is fluid, why logical inconsistencies go unnoticed, why emotional intensity can be heightened without a sense of alarm. The partial reactivation of prefrontal function during lucid dreaming appears to occur against this backdrop of reduced norepinephrine and serotonin, giving lucid awareness a quality that is neither fully waking nor fully dreaming. Dopamine, the neurotransmitter most associated with motivation and reward, is also implicated in dreaming. Research suggests that dopaminergic activity contributes to the motivational and goal-directed aspects of dreams. The sense that something needs to happen, that a destination exists, that the dream narrative is moving somewhere. In lucid dreams, where the dreamer can set intentions and pursue them, this motivational quality becomes consciously usable rather than merely ambient. The thalamus, a small but vital structure deep within the brain, acts as a relay station during both waking and dreaming. During REM sleep, it continues to send signals to the cortex, contributing to the sensory richness of dreams. What changes is the source of those signals. Instead of incoming information from the outside world, the thalamus during dreaming largely relays internally generated patterns, memories, émotionnelle association, and the brain's own predictive models of experience. The world of the dream is, in this sense, a world of pure internal signal, the default mode network, a set of brain regions active when the mind is not focused on a specific external task, associated with self-referential thinking, daydreaming, and autobiographical memory, shows distinctive activity during REM sleep. Some researchers have proposed that dreaming is, in part, an expression of the default mode network operating without the constraints of sensory input. Lucid dreaming, with its addition of self-awareness, may represent the default mode network and the executive network operating simultaneously, a combination rarely seen in any other mental state. Memory works differently in dreams. During ordinary dreaming, episodic memory, the ability to recall specific events from waking life, is significantly reduced. This is why dreams feel disconnected from daily life, why they draw on fragments rather than complete narratives, and why they so often blend different times and places without apparent logic. In lucid dreams, episodic memory improves somewhat, allowing the dreamer to remember who they are, where they are sleeping, and what they intended to do when they became lucid. The phenomenon of source monitoring difficulty, the reduced ability to correctly identify where a thought or memory originated, is common in ordinary dreams. A character in a dream may feel familiar without the dreamer being able to recall their actual name. A place may seem like home, even when it bears no visual resemblance to any real location. Lucid dreaming partially repairs this deficit, allowing the dreamer to trace the origins of dream content back to waking life and to recognize, with a quiet clarity, that the experience is internally constructed. The anterior prefrontal cortex, specifically a region called the frontopolar cortex, is consistently associated with lucid dreaming in neuroimaging research. This area is linked to prospective memory, the ability to remember to do something in the future. When a lucid dreamer successfully becomes aware inside a dream, this region is thought to carry forward the intention formed before sleep, the intention to notice when one is dreaming. The dream itself becomes the context for that future memory to be retrieved. Experienced lucid dreamers show structural differences in brain anatomy compared to those who rarely experience lucidity. A 2015 study from the Max Planck Institute for Human Development in Berlin found that frequent lucid dreamers had greater gray matter volume in the frontopolar cortex, the same area associated with metacognition and self-reflection during waking. The study compared 31 frequent lucid dreamers with 31 participants who never or only rarely experienced lucid dreams. Whether this structural difference is a cause of lucid dreaming, an effect of it, or some combination, remains an open and interesting question. The experience of time in a lucid dream does not appear to run significantly faster or slower than waking time. Researchers tested this using eye signal protocols, asking lucid dreamers to estimate intervals of 10 or 30 seconds while dreaming. The estimates were remarkably close to real elapsed time. Closer, in fact, than many people achieve while awake and distracted. Whatever the dreaming brain is doing, it maintains a relatively accurate internal sense of duration. Even when the experience of time feels subjectively unusual, pain is rarely experienced in dreams, even in lucid ONs. Most dreamers report that injuries and threatening physical events in dreams do not produce the sharp, immediate sensation of waking pain. Some researchers attribute this to the fact that pain processing pathways, including regions of the anterior cingulate cortex and the somatosensory cortex, are less fully activated during sleep. The dream body can be harmed within the narrative without triggering the full alarm response that waking pain involves. Emotions, by contrast, are often intensely present in dreams, and in lucid dreams especially. The amygdala, the brain's primary emotional processing region, is highly active during REM sleep, often more so than during waking. This is one reason why emotional dreams can feel more affecting than many waking experiences. The emotional system is running at full capacity, while the moderating influence of the prefrontal cortex is reduced. In a lucid dream, where some prefrontal function is restored, the emotional intensity does not necessarily decrease. What changes is the dreamer's relationship to it. The visual experience of dreaming is generated almost entirely by the brain itself, with minimal input from the eyes. The visual cortex is active during REM sleep, processing imagery drawn from memory and imagination rather than incoming light. Dream images are not replays of stored recordings. They are reconstructions, synthesized in real time from fragmentary memory traces, émotionnelle association, and the brain's own generative patterns. This is why dream landscapes can be entirely unfamiliar, why dream faces can seem to blend features of multiple people, and why dream light seems to come from no single source. Halfway through the middle phase of our journey, a pattern is clearly forming. The brain during dreaming is not a passive screen onto which experiences are projected. It is an active generator, constructing, synthesizing, predicting, and perceiving all at once. And in the lucid dream, that generator becomes partially aware of its own operation. It is building the world and, in the same moment, watching itself build it. Whether that awareness changes the construction, whether being observed changes what the dream generates, is a question researchers are only beginning to ask. You're still here, still drifting through this quiet science with us. Take a slow breath. Notice how your body has settled a little. Since we began, we're exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. A gentle like or subscribe helps another restless mind find its way here too. One quiet tap, one sleepy soul at a time. Let's drift onward together. The question of whether animals experience something like lucid dreaming has no clear answer yet. What is known is that many animals, including mammals and birds, show REM sleep. Rats show replay of daytime maze runs during sleep, their hippocampal neurons firing in the same sequence as during waking navigation. Whether any animal ever recognizes this internal replay as a dream, rather than simply experiencing it, remains beyond the reach of current science. Consciousness, even in humans, is not fully mapped. In other species, its contours are even less clear. Some lucid dreamers report an experience called false awakening, a dream in which they believe they have woken up, only to discover, sometimes after considerable time, that they are still asleep. False awakenings can be nested. A dreamer may wake within a dream, recognize the dream, and then wake again into another dream layer before finally returning to genuine wakefulness. These experiences illuminate something worth sitting with. The brain constructs the experience of waking with the same machinery it uses to construct dreams. And in certain states, that construction can be difficult to distinguish from the real thing. Sleep paralysis. The experience of waking during REM and being unable to move is related to lucid dreaming in complex ways. Both involve the overlap of waking awareness and the sleeping body. Sleep paralysis can be unsettling, particularly when it involves hypnagogic hallucinations, vivid sensory experiences that accompany the paralysis. Some researchers and practitioners suggest that sleep paralysis can be gently converted into a lucid dream by shifting attention inward and allowing the dreaming state to fully take over rather than struggling toward wakefulness. This requires a degree of calm that is easier to describe than to practice in the moment. The hypnagogic state, the transitional experience between wakefulness and sleep, is closely related to dreaming awareness. As the brain shifts from waking to sleep, many people experience fragmentary images, sounds, or sensations that arise without voluntary control. Some researchers believe that the hypnagogic state offers a window into the dreaming mind in its earliest stages, and that practiced meditators and lucid dreamers may be better able to observe this transition without being swept fully into sleep. The boundary between waking and dreaming, it turns out, is less a line than a gradient. Research has found a connection between meditation practice and lucid dreaming. Multiple studies have found that regular meditators are more likely to experience lucid dreams, and that certain meditation styles, particularly open monitoring practices, which involve observing one's own mental states without judgment, are most strongly associated with this effect. The common thread appears to be metacognitive awareness, the capacity to notice one's own experience as it is happening. This capacity, cultivated in waking meditation, appears to carry over into sleep. Mindfulness-based practices have been associated not only with increased lucid dreaming frequency, but also with changes in dream content. Practitioners often report greater emotional ease within dreams, fewer anxiety-driven narratives, and a higher likelihood of engaging thoughtfully with difficult dream scenarios rather than fleeing them. Whether these changes reflect shifts in underlying neural architecture, in cognitive habits, or in some combination, remains an active area of inquiry. People with certain neurological conditions have been found to have different rates of lucid dreaming. Individuals with narcolepsy, a condition characterized by disrupted boundaries between sleep and wakefulness, report unusually high rates of lucid dreaming, as well as more frequent experiences of sleep paralysis and hypnagogic hallucinations. This connection makes neurological sense. Narcolepsy involves a weakening of the mechanisms that normally keep sleep and waking strictly separate, creating more frequent opportunities for the hybrid awareness that lucid dreaming involves. Research suggests that people who score higher on measures of field independence, the cognitive ability to perceive parts of a visual field independently of the whole, are somewhat more likely to experience lucid dreams. Field independence has been linked to the capacity for self-reflection and the ability to mentally step back from an encompassing situation. The same quality that allows a person to notice a detail within a complex visual scene may also support the capacity to notice one's own dreaming from within the dream. The content of lucid dreams tends to be influenced by the dreamer's intentions and expectations, but not entirely directed by them. When lucid dreamers attempt to summon specific people, entités, or objects, they succeed sometimes but not always. Dream content appears to follow a logic of its own, shaped by emotional associations, recent experiences, and deep memory structures that the aware dreamer can influence but not fully override. This partial responsiveness gives lucid dreams a quality that many practitioners describe as collaborative rather than commanded. Halfway through our journey, the answer to a central question is beginning to form. What is a lucid dream? Really, it is a state in which the brain's capacity for self-observation reasserts itself within the sleeping mind. It is not wakefulness inside sleep. It is something genuinely its own, a hybrid state that shares properties with both, but is reducible to neither. The dreaming world remains dreamlike, fluid, symbolic, emotionally resonant, but within it, a small, clear light of awareness is on. And by that light, everything looks different. Let each breath guide you to realize time is yours, a separate stream that only you are living. Right now, while the vast universe continues to spin, expand, and change, this second you're breathing, listening, is unique. Every thought you've had today, every dream you'll have tonight, is unrepeatable. Cherish the present moment, knowing that right now, your time is unique in the universe, and we continue drifting. Every human being who has ever lived has dreamed. Dreaming appears across all cultures, all eras of recorded history. all conditions of waking life. It is not a luxury of the rested or the peaceful. It occurs in poverty, in illness, in grief, in joy. The brain does not stop dreaming because life becomes difficult. If anything, emotional intensity in waking life often intensifies the dreaming that follows. Sleep does not escape from experience. It processes it. The average person spends approximately 2 hours in dreaming sleep each night. Over a lifetime of 70 years, that amounts to roughly 6 years spent inside dreams, 6 years of internally generated experience. Landscapes, conversation, emotions, entire narratives, occurring in a space with no physical location, no external verification, and no permanence beyond the faint traces left in memory each morning. The sheer scale of this private inner life is rarely considered. Dream recall is highly variable. Most people remember only fragments of their dreams, and those fragments fade quickly after waking. Research suggests that the transition from sleep to waking involves a brief window during which dreams are most accessible, and that this window closes rapidly as the waking brain's activity patterns reassert themselves. People who keep dream journals, writing down whatever they remember immediately upon waking, tend to improve their recall noticeably over time, suggesting that dream memory is a trainable capacity rather than a fixed one. The content of dreams is not random. Studies analyzing large collections of dream reports find consistent patterns. Dreams are more likely to feature familiar people than strangers. They more often occur in indoor settings than outdoor ones. Negative emotions appear more frequently than positive ones, and physical activities, running, walking, interacting, are far more common than passive observation. The dreaming mind appears to draw preferentially from certain categories of experience, returning again and again to the emotional textures of daily life. Lucid dreams tend to differ from ordinary dreams in specific ways beyond the presence of awareness. They are reported as more vivid, more emotionally positive, and more likely to involve deliberate action by the dreamer. The narrative coherence of lucid dreams is often higher. They tend to make more internal sense, follow more consistent patterns, and feel more like navigable environments than the fragmented, shifting landscapes of ordinary dream. Awareness, it seems, gently stabilizes the dreaming world. The question of whether the people who appear in dreams have any independent existence, whether dream characters are purely projections of the dreamer's mind or something else, has no scientific answer. From a neuroscientific perspective, every person in a dream is generated by the dreamer's own brain, drawing on knowledge and emotional associations related to real or imagined others. But the experience of encountering dream characters who act unpredictably, who say things the dreamer did not consciously choose, who quietly resist the lucid dreamer's attempts to direct them, is widely reported and not yet fully explained. Some lucid dreamers describe conversations with dream characters that feel, in the moment, genuinely surprising, as if the character holds knowledge or perspective the dreamer did not already consciously possess. From a neuroscientific standpoint, this may reflect the depth and complexity of the unconscious processes that generate dream content. The brain knows far more than consciousness can access at any given moment, and dreams may sometimes provide a channel for that deeper knowledge to surface in the form of apparently external voices or perspectives. This is worth pausing on, gently. The relationship between creativity and dreaming has been studied for decades. REM sleep is associated with improved performance on tasks requiring novel associations, connecting distantly related concepts in unexpected ways. This enhancement of associative thinking during and after REM sleep is thought to contribute to the well-documented phenomenon of insight upon waking, the solution that arrives in the night, the unexpected connection noticed with morning clarity, lucid dreaming, which makes this associative space deliberately accessible, has been explored by artists, writers, and researchers as a creative resource. The German chemist August Kekulé famously described arriving at the ring structure of benzene through a dream image of a snake seizing its own tail. Salvador Dalí developed a method of capturing hypnagogic imagery by resting while holding a key above a metal plate, so that the sound of it falling would wake him at the threshold of sleep onset. Whether these accounts are entirely precise is uncertain, but the intuition they reflect, that the dreaming mind has access to something the waking mind does not, carries a degree of neurological grounding. REM sleep genuinely does loosen the usual constraints on association. Grief, loss, and profound life changes often find their way into dreams. People who have lost loved ones frequently report dreaming of them, sometimes in scenarios that feel consoling, sometimes in scenarios that seem to replay the loss. Some grief researchers have proposed that these dreams serve a function, allowing the morning mind to continue processing emotional reality in a space where the usual rules of time and permanence are suspended. Lucid dreamers occasionally report choosing to enter such dreams with awareness. The therapeutic possibilities of this remain a sensitive and developing area of research. The relationship between dreaming and memory consolidation is one of the best established findings in sleep science. During NREM sleep, non-rapid eye movement, sleep, the hippocampus replays recent experiences, transferring information to the cortex for long-term storage. During REM sleep, emotional memories are processed and the connections between them are refined. Dreaming appears to be part of not incidental to. This process, to dream is, in some meaningful sense, to consolidate. A growing body of research suggests that REM sleep specifically supports the processing of emotionally difficult experiences. Studies have proposed that REM sleep allows emotional memories to be revisited in a neurochemical environment with reduced norepinephrine, enabling the brain to process charged experiences without the full physiological stress response active during waking. Over multiple sleep cycles, this may gently soften the emotional edge of difficult memories. Dreaming, in this view, is not just storytelling. It may be a form of quiet, involuntary repair, persistent disruption of REM sleep through short sleep duration, alcohol use, or certain medications, impairs this emotional processing function. People with chronically disrupted REM sleep tend to show heightened emotional reactivity and greater difficulty regulating mood over time. The dreams we forget upon waking may be doing more for us than we ever recognized while we were awake. Lucid dreaming has been explored as a potential tool for people with post-traumatic nightmares, specifically because it allows engagement with distressing dream content rather than simply enduring it. A lucid dreamer who becomes aware during a nightmare can choose to interact differently with its elements, to speak to a threatening figure, to alter the direction of the dream, to remind themselves that what is happening is not real. Multiple clinical studies have found reductions in nightmare frequency following lucid dreaming training. Though the evidence base is still carefully developing, we now understand that the dreaming mind is not an afterthought of consciousness, a noise produced by a brain that cannot fully switch off. It is a state with its own architecture, its own chemistry, its own purposes, and its own forms of knowing. Lucid dreaming does not interrupt this state. It accompanies it, a witness arising within the dream. Without dissolving the dream itself, the awareness and the dreaming coexist, quietly, like two things that were never really separate. The philosopher Thomas Nagel famously asked, "What is it like to be a bat?" His point was that certain forms of consciousness may be genuinely inaccessible from the outside, not because they are mysterious, but because they are fundamentally first person. Dreaming raises a similar question. What is it like to be inside a world entirely constructed by your own mind? Lucid dreaming offers the rare possibility of asking that question from within the experience, with enough awareness to notice what the answer feels like. The philosopher and cognitive scientist Thomas Metzinger has written about lucid dreaming as a window into the nature of selfhood. In a lucid dream, the dreamer has a body. It can be seen, felt, and moved, but it is entirely constructed by the brain. The self that inhabits the lucid dream is real in experience, but has no physical substrate in the dream world. Metzinger suggests this reveals something worth considering about waking selfhood, that the sense of being a self located in a body in the world is always a construction, just one that is usually very well supported by sensory evidence. The concept of the phenomenal self model proposes that what we experience as the self is a real-time model, the brain constructs of its own state. In ordinary waking life, this model is tightly constrained by sensory input, proprioception, and memory. In dreams, the sensory constraints are lifted, and the model becomes more fluid. The dream body can fly, pass through walls, change in ways that would be impossible otherwise. In lucid dreams, the dreamer watches this fluid self-model with a degree of gentle detachment that is rarely available in waking life. The model is still running, but the awareness watching it has partially stepped back. Some researchers have proposed that the ability to lucid dream may be related to a broader capacity for self-referential awareness, a kind of mental flexibility that allows a person to shift between being immersed in an experience and observing it from a slight distance. This capacity has been linked to psychological resilience, emotion regulation, and lower rates of rumination. Whether lucid dreaming training directly strengthens these capacities in waking life, or whether people who already possess them are simply more likely to lucid dream, is a question research has not yet fully resolved. Sleep technology has advanced in recent years, and with it, the possibility of more accessible tools for lucid dream induction. Wearable devices that monitor REM sleep and deliver gentle auditory, tactile, or light cues during REM periods have been developed by several research groups. Results in controlled studies have been mixed, with some showing modest increases in lucid dream frequency and others showing minimal effects. The challenge of delivering a signal detectable within a dream without disrupting sleep remains technically delicate. Binaural beats, audio stimulation in which slightly different frequencies are presented to each ear, have been explored in relation to dreaming. The scientific evidence for their effectiveness as lucid dream inducers is limited and inconsistent. Some studies suggest modest effects on dream vividness or REM duration. Others find no meaningful difference. The brain's response to this kind of auditory stimulation appears to vary considerably between individuals, and the conditions under which any effect might arise are not yet well characterized. As with so much in this field, the honest answer is that more careful study is needed. The neuroscience of consciousness, how and why physical processes in the brain give rise to subjective experience, is one of the deepest unsolved questions in science. Lucid dreaming. Because it presents a state in which consciousness is clearly present without most of the usual conditions we associate with it. Sensory input, physical engagement with the world, normal neurochemistry, offers researchers a natural opportunity to study awareness stripped of its usual scaffolding. What remains of consciousness when almost everything else is removed? Lucid dreaming suggests quite a great deal. Integrated information theory, one of the leading theoretical frameworks for consciousness developed by neuroscientist Giulio Tononi, proposes that consciousness arises from the degree to which a system integrates information, the extent to which the parts share information in a way that could not be reduced to the sum of its parts. By this measure, the dreaming brain, with its high degree of internally integrated activity, would qualify as conscious. Lucid dreaming, with its added metacognitive layer, may represent a particularly rich form of that integration, all generated from within. Global workspace theory, associated with cognitive neuroscientist Bernard Baars, proposes that consciousness arises when information is broadcast widely across the brain via a shared central system. During ordinary dreaming, some aspects of this global broadcasting appear active, accounting for the sense of presence and experience within dreams. During lucid dreaming, executive regions, the prefrontal areas associated with self-awareness, appear to be added to that broadcast, allowing a more self-reflective, wider form of awareness to emerge. And so, 3/4 through our journey, the answer is taking shape. Lucid dreaming is not a trick of the mind. It is a measurable, reproducible, neurologically distinct state of consciousness, one that continues to illuminate the architecture of awareness itself. What it shows us is that consciousness is not a single thing. It is layered, modular, and more flexible than most of us ever notice. And within sleep, that state we spend 1/3 of our lives in, layers of awareness are possible that most of us never encounter, simply because we never think to look. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles, each sleep cycle flowing gently into the next. You're breathing in, we out, in, out. A small rhythm within the vast rhythm of the night. You are part of that movement. You don't need to hold on to any of this. Let everything unfold in its perfect order, like the slow turning of the earth beneath you, unhurried, unresisting, simply existing. We're almost there now. Every night, without exception, your brain enters a state that no technology has yet replicated. It generates experience from memory, It feels entirely real. You are there, and then you are not. And in the morning, most of it is gone, leaving only the faintest residue of something that felt, for a moment, as real as anything waking life has ever offered. The dreaming brain does not experience itself as dreaming. It experiences itself as living. This is not a failure of intelligence or discernment. It is how the brain is built. The same neural machinery that constructs waking experience also constructs dreaming experience. And both feel, from the inside, equally present. Lucid dreaming does not require exceptional talent. Research suggests it is a trainable skill, not an innate gift. Most people who consistently practice awareness techniques, reality checks, intention setting, keeping a dream journal, show improvements in lucid dream frequency over a period of weeks to months. The door is more open than it might seem. The dreaming mind is not trying to confuse you. It is organizing. It is processing. It is doing the patient, invisible work of making sense of everything that has passed through you during the day. The emotions, the encounters, the questions you did not have time to sit with while waking. Allow it to work. There is a reason dreams so often return to places from our past. The brain's memory systems are weighted toward emotionally significant locations. The home of childhood, the classroom, the landscape of a formative experience. These places carry emotional charge, and the dreaming brain returns to them the way a hand returns to a familiar surface, finding something there it still needs. When you become lucid in a dream, you do not need to do anything with that awareness. You can simply be there, in the dream, knowing it is a dream, without changing a single thing. Some practitioners describe this as the most peaceful form of lucid dreaming, to stand quietly inside a world the mind has made, and simply witness it with no agenda at all. The sensory richness of a vivid dream can feel unlike many waking experiences. Colors can seem more saturated, space is more vast, emotions more unguarded. This is the brain running without the dampening effect of survival priorities. Free, for a few minutes, to generate experience at a different kind of intensity. This is offered here as a subjective impression, the kind many dreamers describe, rather than a measured claim. Some people dream in color. Some dream primarily in shades of gray. Surveys conducted before and after the widespread adoption of color television found a notable shift in color dreaming across generations, suggesting that the visual content of dreams is shaped, in part, by the visual media we absorb while awake. The dreaming mind is not separate from culture. It reflects it, quietly and faithfully. The experience of flying in a dream is one of the most commonly reported. Flight dreams tend to be associated with positive emotional states, a sense of freedom, lightness, open space, and are frequently cited by people as among their most memorable dreams. Lucid dreamers, who develop the ability to fly in dreams, often describe it as among the most peaceful experiences the dreaming state offers. The brain stem, among the most evolutionarily ancient parts of the brain, is involved in generating the REM state. The neurons that initiate REM are located in a brainstem structure called the pons. They have been conserved across hundreds of millions of years of evolution. When you dream, you are using neural machinery that fish and birds also use, that your most distant vertebrate ancestors used long before humans existed. Dreaming is very, very old. Children spend a higher proportion of their sleep in REM than adults do. Newborns spend approximately 50% of their sleep time in REM, far more than the roughly 20% typical of adults. Some researchers have proposed that this abundance of REM in early life supports the rapid neural development of the young brain, helping to connect the vast number of new pathways forming in those early months and years. To sleep as an infant is, in some sense, to grow. As we age, REM sleep tends to decrease. Older adults generally spend less time in REM than younger ones, and dream recall often diminishes alongside it. The reasons are not entirely clear, but changes in sleep architecture, neurochemistry, and circadian rhythms all appear to contribute. The rich dreaming of youth does not disappear entirely. It simply becomes, for most people, quieter, shorter, and less easily held. Your brain creates entire worlds while you sleep. Every night, during REM sleep, your mind constructs vivid experiences from memory fragments, emotions, and abstract patterns. Characters appear, conversations unfold, and landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and even physical sensations, yet they vanish upon waking, like morning mist. The sleeping brain is not resting, but creating, exploring possibilities that waking life never quite offers in the same way. In a lucid dream, the world is yours to observe. You did not make it consciously, but it came from you. Every person in it, every landscape, every room that does not quite match any room you have known. They emerged from the accumulated weight of everything you have ever seen, felt, or imagined. There is something quietly worth noticing about that. Could lucid dreaming change how we understand consciousness in meaningful ways? It already has. It has shown us that awareness is not binary, on or off, awake or asleep. It is a spectrum, and somewhere along that spectrum, there is a place where sleep and awareness coexist, where the brain dreams and knows that it is dreaming, and the knowing does not end the dream. Many things remain unknown. We do not fully understand why some people lucid dream easily and others rarely, if ever, do. We do not have a complete account of the function of dreams beyond the broad areas of memory, consolidation, and emotional processing. We do not know what the sleeping brain experiences between dreams. In the quiet intervals of deep NREM sleep, where neural activity slows almost to stillness. These are not failures. They are open invitations. What we do know is this: the sleeping brain is not empty. It is not merely resting, waiting for morning. It is doing something complex, something ancient, something that appears to matter for nearly every aspect of psychological and physical health. Sleep is not the absence of living. It is another form of it. And perhaps that is what lucid dreaming shows most gently. Beyond all its neuroscience and its techniques and its clinical possibilities, it shows that the inner life does not stop when the outer life goes quiet. The mind goes on. The awareness if gently tended, goes on too. Even in sleep, even in the dark, you do not need to become a lucid dreamer to take something from this. The same gentle attention that supports lucid awareness, the habit of noticing, of asking softly, of being present to what is actually happening, is available in every waking moment. The dream is just one place it can go. And tonight, whatever you dream, whether you remember it or not, whether you know you are dreaming or drift through it, completely unaware, something is happening. Your brain is working, tending, weaving. Tomorrow, something will be quietly different for it, in ways too subtle to name. Sleep is never wasted, not 1 minute of it. And so, our quiet journey through the science of lucid dreams comes to a gentle close. We traveled from the first laboratory signal, recorded on the morning of April 12, 1975. Those deliberate eye movements that proved awareness could exist inside sleep, to the real-time exchanges now held with sleeping minds in research laboratories on multiple continents. We visited the prefrontal cortex waking partially, while the rest of the sleeping brain continues its ancient work, and we found that even the brainwave signatures of lucid awareness are still being carefully revised as new evidence arrives. From the earliest written record in Aristotle's writings on dreaming, to the 2021 conversations held with sleepers from 4 countries at once, we have glimpsed how vast and unmapped the territory of the dreaming mind remains, and how much has already been quietly, carefully understood. Lucid dreaming reminds us that awareness is not a fixed or finished thing. Much of the mind's deepest work happens in silence, in darkness, in states we cannot reach with ordinary waking attention. The dreaming brain reveals patience, depth, and a kind of knowing that waking logic rarely touches. Without sleep, without these long, unmeasured hours of internal processing, that knowing has no place to surface. By pausing to learn about it, even gently, even at the edge of sleep, we glimpse something extraordinary in the most ordinary act of closing our eyes. In these final minutes, take the deepest breath you can, as deep as possible. Think about unity, of every thought, every dream, every moment of awareness that has ever arisen and dissolved in the space behind closed eyes. You are not separate. You are a link in the endless chain of minds that have slept and dreamed and wandered through the long human night. Think about consciousness itself. Yours, mine, everyone listening. All awareness everywhere. Perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Let your entire being dissolve into the space between waking and sleeping, where thought becomes image, and image becomes rest, and rest becomes something beyond either. Prepare for deep sleep. No boundaries left, only peace. If this quiet exploration of the dreaming mind brought you any peace tonight, a gentle like or subscribe could guide another restless mind here. Someone lying awake right now, needing exactly this. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight. Inward. Through corridors most people never pause to notice. You touched the architecture of your own awareness and found it more fluid, more gentle, more forgiving than it seemed. You can allow these thoughts of dreams and consciousness to fade now. like the last image of a dream at dawn. Present, then softer, then simply part of everything, leaving only the quiet, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if all you've carried today is being sorted by careful, invisible hands, and is simply setting itself down. If sleep comes, let it carry you the way the dreaming mind moves. Not with force, not with destination, but with the patient, unhurried logic of something that has always known where it is going. Into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the dreaming brain will still be there, still tending, still weaving, still becoming. But tonight belongs to stillness. Rest well, gentle explorer, and remember, even in the deepest sleep, something in you is always quietly aware. Good night.
you.